Today we'll be moving further on OWASP top 10. Last week we talked about broken access control, we talked about cryptographic failure when we did some simple labs on them. Today I will continue with injections, insecure design, and security misconfiguration. I'll try my best to wrap up the remaining parts in 2 episodes so that we can move on to other topics. So as I mentioned, we'll be going through the OWASP top 10, the continuation from broken access control and cryptography failure like we did last week. So this week we'll continue with injection. Like I mentioned, we'll go through the lab for injection, we'll go through the lab for insecure design and security misconfiguration. For this week, I will try my best to make it as simple as possible. It might be a little, kind of mid-level for people who are not very familiar with Linux command, but it's still very simple. As simple as possible, I'll break it down. I'll take away the difficult parts and explain it properly. So let's first of all start with what is injection. I like to compare simple English with cybersecurity terminology. So injection is like you're injecting into something, really. Injections are very common with applications. They have flaws. In application, it could come in form of command injection. It could come in form of SQL injection. We all know what SQL is. It's related to database. It's related to queries. So when an attacker could find a flaw or a vulnerability where they can have an input into whatever. It could be your URL, it could be something that requests something from your server, resource from your server. So that's generally what injection is about. And as you can see, it's like a user-controlled input, what a user have control over. They can pass in an SQL query into it and thereby manipulating the outcome. It could come in form of commands also, which is user input passed into system command. Now, if we are talking about vulnerability, how then can you control this? By doing an allowed list. And I'll explain this a little further. So allowed list would mean that if I say, for example, you have a username and you have a password. Now, I know that you've logged in some cases before where the system will tell you, you need a special character, or whatever you have imputed would not go through. Now, I'll use the example of my surname. I have a surname that is hyphenated, really. So sometimes on some platform, when I put my surname with hyphen, I get something back. Sometimes, mostly in airlines, I get an error back saying that I've imputed a character that they don't recognize, and that's because they have something called input validation. I won't go into details. What I'm trying to say with allowed lists is that a developer could develop or build or have in their code a list of what is allowed. And in this way, you're trying to prevent this attack called injection. Because if you have what is not allowed, then if an attacker is trying to put an unallowed input into a script, into a URL, then the application would reject it. And these are one of the ways to guide against, injection. I just wanted to put that out there. And also there's something called stripping input. So stripping input is like when there is a dangerous character imputed, they are removed before processing. So it doesn't get processed, they are removed because they already have recognized them as a dangerous character while building the application. So now for this part, we have completed it. So I'll explain a little bit about this command injection. Like I mentioned before, it could be a server-side, kind of code on a website, making a call for a function into a server console, which shouldn't be, because a user shouldn't be able to, an attacker should not be able to have, a say over what, happens in the server, right? Now, they gave an example. This example might be a little high level for beginners, but I will try my best to explain it. Now, this is a simple code, a code example of, I'll just go a little further just to let you know what the code means. So now, what all of this means, they are called parameters when it comes to application. These ones in double quotes, they are called parameters. So now for the first quote is checking if the parameter money is set. Now, if it is, then the variable get passed into the input. So here it is checking if it's set. If it's set, then it's passed into as an input into an input field. Now, if cow is also set as a parameter, and this is for people who are very familiar with codes and all the rest, then it get passed also into the input field. Now, the last part of the code is called pass-through. So in this form of code, what they are trying to show us, as in what TryHackMe is trying to portray, is that this is left without input validation. So when it is left without input validation, then anything can be passed in the place of these two. So that's the vulnerability when you leave your code open-ended. So like I mentioned that I had issues with airline before trying to impute my surname. So if they had left it open-ended without adding, some kind of what is allowed, then I'll be able to just freely put my, surname, put a double hyphen if I want, put a $sign, which shouldn't be in people's surname, right? I should be able to do that. But because they have input validation, they have stated what they want in their allow list, then I'm not able to. So that's what this little code is just showing here, that there is no input validation, so you can enter in anything. Like you see that the pass-through function simply executes a command in the operating system console. It calls for a command server side. And because it does call for a command, we can try adding additional command by simple tricks. So eventually, this is what we'll be using for our lab, eventually when I start the machine. So they're also showing us, a little bit of how to exploit some of this command using something like who am I. So who am I just shows you the user, like the username you have. Who are you on that box? As you can see from the screen, Jdo at, attack box. Now, when you use the command who am I, for people who are very familiar with this command line, it just shows you that, and because you are using echo, so it echoes all this word out and then input who am I inside of it, which is my username is Joenjo. Echo command just display what you want it to display. For example, everything in these double quotes comes out. If you echo a hello world, it comes out as hello world. That's what echo means. And then who am I is showing you who are you as the user at that point. Which username are you using? If on your system you have username for yourself, for your sister, if you're using a username at the point for yourself on the attack box, then it displays your own username. So that's who am I. There are different commands to use, and eventually I'll be taking you through fundamental Linux command, and with that this particular lesson will make more sense. But at high level, I feel when we go through the lab, we'll be able to understand better what all of this means. Now I'll start up the machine, and then we would go into what the task looks like. We've gone through this little code. These are a few commands you can use, to check if config. It will show you, if config or IP address and all of that. Now we'll go through the command, the labs, and we'll be able to see what we can do with the lab. And I'll explain it step by step. We'll see from there. Let me start the attack box. This is how we're able to see the machine. So now let's go back. Once the machine starts, we'll be able to see the IP, because we are supposed to navigate to that IP and exploit the server. So what we are trying to do is to exploit this line of code to pass in other things, so that we can see other information that we normally shouldn't be able to see. So once we pass other line of commands into the box, into this box, we'll be able to see different information. Normally, as you can see from their display, they passed in TryHackMe into it, and TryHackMe was able to display instead of, as opposed to what was here. Okay, this part could be the cow, and then this part would be, display what you have on this screen. And because anything can be passed into it, as you can see, the cow was here as default cow. We have different types of, cow that you can choose from. Now, the header of what would be displayed can be changed. Instead of input validation holding it down here, it has that vulnerability where you can pass in everything. I hope I've been able to, to do justice to it a little bit. I know this can be a bit tricky for somebody who is an absolute beginner, but if you follow the lab, you'll be able to, to bring together what I'm trying to explain and, what we have in the lab. I hope it makes sense to you eventually. So let's go into it. We have our IP, which we believe, IP domains, like I explained. And by now, you should already know how that works. So we have, as you can see, we have the display from the IP in the attack machine. And now, so as we said before, that this is something that we can pass in anything because of the vulnerability attached. So let's just play around with it and see what is this. As you can see, this is empty. This is a default cow. We can decide to change it to a smaller cow or something. Okay, we couldn't. I think I tried it before. Can't remember if I have, or maybe I need to enter something here. Okay, I'll just try to enter something here and see. Yes. Okay, I think if you enter something, then you get to change the type of cow you can choose from, blah, blah, blah. So now, because we know that we can actually run a command here because it has vulnerability, because the input is not validated. So they are asking us, what is the strange text file in the website root directory? We are not supposed to see it normally. And if you want to see what is in the root directory, like I said, that I'll be teaching fundamental Linux command eventually, but one of the commands to use when you want to display things is ls. So because we are running it as a command, of course, we have, $sign with it. And we can see if it displays what we want to be able to see. As you can see, yes, the cow is displayed, but we're able to get something from the root directory of the website, which we are not normally supposed to be able to get. You're not supposed to have access to this part of the application. Now, it says what strange text file. As you know, text file ends with txt. So we'll just copy this, bring it back. Bring it back here. And let's see if it works. So as you can see that because the input is not validated here, they are able to enter in TryHackMe mode, and then it displays on top of the cow. And this is because the application, when building the application, the input was not validated, so you can run in anything that is supposed to be user controlled to access server information. Now, they're also asking us how many non-root, non-service, and non-daemon users are there. So in this case, it's a little tricky, it's not simple, but because I have an idea of what a standard user should look like, so we'll use a particular command. We have a file that often display, what type of users we have. The file is /etc/passwd, we call password. So now we'll run the command, and whenever you want to display something in Linux, you usually use cat. Whenever you want to go into the editor in Linux, you can use Vim, you can use nano. And these are the little commands that I said I would, teach as Linux fundamentals. So let's also try to run the command. So let's say cat /etc/password. So as you can see this, and then we are able to see users, root users, whatever, and they're asking us non-root users. So if we go through all of these users that we have, we'll be able to see that there is no non-root user, like standard user. So opposite of non-root user is normal standard user. Now, there are a few things to identify standard users. First of them is the user ID of a standard user begins with 1,000. It's nothing less. And as you can see all the numbers here, there's nothing, less than, more than 1,000 here. As you can see, the last one is 100. There's nothing less than 1,000. That's one of the ways to identify which ones are, standard users, sorry. That's how to identify. And the other part to identify is that the SBIN has /no login. So I would show you from here when I try to use find no login. So if we try to look for, SBIN no login, as you can see, we have so many SBIN no login, and that means that they are root users. They are not standard users. They are not normal users. So from all of the display users that we have, I think the default one is that none of the standard user has a user ID of less than 1,000. I think that is simple enough for you to be able to identify standard user. So in this case, the answer is 0 because none of these users have user ID greater than 1,000, and that works. Now, they're also asking us what user is running in the application. And at the beginning of the lesson, I mentioned something called who am I. So if you want to know who you are, you just need to type in who am I. That command is quite simple. So who am I? Like to see who you are logged in as. And when you click on who am I, you see it's Apache. So the answer here is Apache. You are logged in as an Apache user. As you know, initially when I ran this command, you could see the number of the users that we have. And at the end, you would discover that we have a user called Apache. So with a user ID, I think of 100, I think to 101, something like that. But one of these is the user ID. One of these is a default placeholder for password. That's how it's being read. Now, they say, what is the user shell set as? And as you already know, the user shell is set as SBIN. We've seen what SBIN is. We've seen what SBIN is from the initial display. So this is what is set at. And they're also asking what version of Alpine Linux is running. So if you want to know the version of Alpine Linux rather that is running, it's usually a command line with cat, I think OS release, something like that. I'm not like sure. I need to check, like to double check, or /etc OS release or something like that. Okay, so that didn't work. One moment. /etc/OS release. Okay, so it's etc OS release. That's the directory that leads to it. So we see the Alpine, but they're asking us for the version. So the version is 3.16.0. That's the version. So we can submit and see. And yes, we just finished the injection lab. And I hope this makes sense to somebody. Now let's go to the next one, insecure design. Now insecure, I'll explain a little bit about insecure design. So in a CI/CD pipeline for developers, when you incorporate security into development, which we refer as a DevSecOps. So how the process works is that there is a design phase, there is a coding phase, build, deployment, before you push it to the guys in operation. Once you deploy, they start to monitor, and then, continuous whatever development, start to monitor and the rest. So now the first step in the CI/CD pipeline is design. So first of all, you are doing design, you're doing a data, flow diagram, you're doing the threat modeling. This is the first place. You're looking at the entry points, the exit point of the application you're trying to build. And this is why this vulnerability is also very important, because this kind of vulnerability, when it happens, you have to build that part from scratch up. And I'll show you, from this TryHackMe lab. So this is a vulnerability that is inherent to the architecture, how the application is being built. It's not based on configuration or what you have imputed down the line, is the build form. So now they explained to us how that a while ago, Instagram had such vulnerability. So how we work with Instagram is that when you forget, when you want to reset a forgotten password, now they send you a 6-digit code to your mobile phone. And there's something called rate limiting. So when they send you this 6 code, normally you have, they place it at 250 before they block you out. So in this way, they are trying to prevent an attacker, So even if an attacker is trying to brute force this code, because for a 6 code, there is a number of times they can try random codes together, all those probability and statistics. Now, because there's a rate limiting of, blockage after 250 attempts. Now, what Instagram did not do is that they make sure that rate limiting is restricted to one IP. So, as you can see from the TryHackMe explanation, it states that for a 6-digit code, we have different possibility, blah, blah, blah. Now, it is code per IP, one IP. So if I'm trying it on my phone that has one IP, so I can try 250 times before I'm blocked out. Now, what they did not understand is that an attacker could use different IPs to make sure they get the right code. Now, different IP, what are we referring to? We're referring to like 4,000 IPs. So you could wonder that, okay, 4,000 IP is a lot and it's not possible. But with cloud, you can always get it. As you can see from the display, random IPs can try out the code and eventually get through to it. Now, when this type of vulnerability happens at the beginning, like I mentioned before, that it will take you building that part of the architecture from ground up again. And the best part is to avoid such vulnerability is to perform threat modeling, which I'm not going to threat modeling, but threat modeling is you're checking different things. So, for example, there's a part of threat modeling called stride. So that stride is you're checking for spoofing, you're checking for tampering, you're checking for information disclosure, you're checking for repudiation. It means that can a user do something on the application and deny that they've done something on the application? You're checking for elevated privilege. Can they elevate their privilege from being a user to being an admin? That kind of thing. That's what threat modeling is referring to. So it is better to perform a threat modeling at the beginning, get all your information right, and design a proper application. That's why we are also advocating for shifts left. Design a proper application where you have incorporated security from the beginning before you proceed, or else you'd have to, go back. Now we have a practical example that we'll be using. This is the IP that I would be using. And from this IP, we were asked to do a simple task, and the task says, try to reset Joseph password. Keep in mind, the method used by the site is to validate if you are indeed Joseph. Now, we want to check if we can log in as Joseph. We don't have Joseph password, but we know Joseph is a user, right? Now, these are one of the ways to check for, whether we can spoof or we can tamper with information. So, and this is for training purpose only, like you already know. Now, if you want to, reset somebody's password, the first thing you do is, I forgot my password, right? We know the username. The username is Joseph. Username is Joseph. So let's try. Now, because when you want to reset your password, they ask you different random questions. What's your dog's name? Where's your first primary school? Where's your primary school? Or what's your mother's son's nephew name? Now we have 3 questions. The simplest of the question is the one we should target, which is, what's your favorite color? It's easy to get people's favorite color. It's the most simple thing, because we have primary colors, we have secondary colors. I doubt if somebody's favorite color will be crimson, red, or something like that. But, let's see. Favorite color is a guy. Joseph is a guy. So the first thing that comes to my mind is blue. Let me check, because men like blue color. So I will check. Okay, well, it's not working. Okay, so I would also try to check white. Some men like white colors. I'll try to check white. Okay, white is also not working. Let's try green and see if we can pull Joseph password with green color, if green is this. And yes, we can, as you can see. So we have Joseph password. I will copy this password. And then they ask us, okay, we have completed this part. They ask us, what is the value of the flag in Joseph's account? So before that, we need to log in first to Joseph's account before we can pull the flag, and already copy Joseph's password, as you can remember. So I'll log into Joseph's account and see. Not now. So we have a note in Joseph's account. Try to see. Remember to move private file out of the server. Okay. No, I don't think we are able. Okay, this is the flag and it's private. Nice. So we're able to see the flag. And then we copy the flag and paste it, and let's see. Yes, it's a correct information. And so we have gone through an insecure design. So what this insecure design is trying to show us is that when your design is not properly fixed, right? Anybody could log in knowing who a user on that platform could be, because your friends could be aware that you use Stanbic IBTC, right? Or your friends could be aware that you use an Access Bank. They could go there, use your username, forget password, try so many questions, and then try to retrieve your password if there is an insecure design. And this is why we advocate that security should be incorporated at every phase of development. So we are done with insecure design. Let's move on to security misconfiguration. I'm trying to beat time, sorry. So now, security misconfiguration is a simple concept to understand. It just means that when security are supposed to be properly configured, they are not, right? Not configuring security, having default accounts without changing the password. Like, for example, I used to tell people, when you get a router in your home, the first thing you want to do is to try to log in and then change your password. I know that I've said this to a couple of people, and they're like, why do I need to change my password? Because the password default from your ISP or provider might just be the password they give every other person. So it's easy for an attacker to just log in and then, laterally move through all your devices. So you want to change default password. You want to make sure that even error messages are very vague. Now, because attackers can log in, put in wrong username or password to get an error. Now, when they get an error, you can also get information out of an error message. So you want to make sure that your error messages are not overly detailed. Also, it's part of security misconfiguration when you have it overly detailed. Now, they cited an example that Patreon was hacked in 2015, and 5 days before it was hacked, somebody saw, an open debug interface for their console and blah, 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 and all of that. Now, they asked us to log in into this IP. To this IP. So now we are in. We can click on complete in this case. We are in, and then they asked us to log into the console of it. So I will go to the console. This is what they asked us to do. So now we are in the console, right? They asked us to run a command and print. So this is like a Python code command. It's saying that it should print ls/l. So ls/l is just displaying the files that you have in whatever directory you're in. Remember, we used it before where I used ls to display the document that we have in the root. So it's the same, it's just written in Python in this case. So I would copy and paste and run it. And here we have all the files, and everything here means something, really. So normally we have owner, we have users, we have group, and all of these RWR, they mean something. They mean read, they mean write, they mean execute. So, but I would be going into this, I think, when I'm explaining some of the directory in Linux and the rest. So now, as you can see that we have, this one also means different thing. User group, dates created. Wow, I think this is like the file, like the MB of the file, and then the names of the file. Now they're asking us a question: what is the database file in the directory? As we know, that database ends with .db, so it's very simple to see. To do .db, that's the answer for this one. It's very simple. .db. So this is security misconfiguration. We shouldn't be able to have access to the files through the console, right? We shouldn't be able to see all of this, and we are able to see them because it was not configured properly. Now, as we see this app.py, it's a Python file, and they ask us the Python file that contains the source code, right? And we shouldn't be able to see where the Python file having the source code. Now they said, what is the secret flag in the source code? It means that we have to actually read this file. And like I said, cat is a very important command. It's powerful. I was recently asked about it. For some very weird reason, I forgot. And I kept telling the person nano, because the person was like, if you want to display something Linux, what will you use? And because I have built a culture of laziness of using nano to display, even if I don't want to edit that file, I just use nano, see what is inside, then you Control X, okay, and then Control O, I think something like that. Control X means save, then okay to retain the name of the file, and Control X to exit the file. And because of I have built a culture of laziness of doing that, I was asked, and then cat never came to my mind. I do use cat, but so cat is a very important command, and we are going to use it here again. They asked us that we should modify the code to read the content of this. So they're asking us to modify this code to read the content of app.py, so we can, which contains the application source code, so we can see the secret flag inside. It's very simple. We just go back to the code we built before, and like it's a Python. So because it's a Python code, we don't even need to mess with every other thing like open, read, print, and thereabouts. We just need to cut that particular file they asked us to display, .py. If you cut it, you just display everything in that file, and voila, you have it. And so we have the source code, so we can go through it to see where the secret flag is. And I think I saw it somewhere. Yes, the secret flag, as you can see, is here. So the secret flag is TMH, TryHackMe, just a tiny misconfiguration. So I'll copy and I will paste it here and submit. And so we have it. And that is the end of our task 5. I'll try my best to go through few other tasks and then just summarize the rest and wrap up this session on OWASP top 10. So see you next time.